Hello and welcome back to the channel Science Math Engineering. Today we are going to solve the Assam Public Service Commission, that is APSC's Assam Electricity Grid Corporation Limited, that is AEGCL 2023 Mechanical Engineering paper for Assistant Engineer Part 4. So let's get started. Question 76. For a cam, the maximum travel of the follower from its lowest position to the topmost position is called, so it is called lift. Okay, next question. The tool used for closing down the edges of the plates and heads of the rivet to form metal to metal leak-proof joint is called, so it is called caulking tool. So next question. In underdamped vibrating system, if x1 and x2 are the successive values of the amplitude on the same side of the mean position, then the logarithmic decrement is equal to, so it is equal to log of x1 by x2. So it is the natural log. So option C is the correct answer. Next question. For a vibrating body, the ratio of energy dissipation per circle to the maximum kinetic energy is called, so it is called specific damping capacity. Okay, it is denoted by beta. So next question. When a shaft is subjected to combined twisting moment T and bending moment M, then the equivalent bending moment is equal to, so it is equal to half of M plus root over M square plus T square. So next question. An open coil helical compression spring A of mean diameter 5 cm is subjected to an axial load W. Another spring B of mean diameter 2.5 cm is similar to spring A in all respects. The deflection of spring B will be dash as compared to spring A. So the answer is, it would be 1 by 8 of the deflection of spring A. So let us see how we can get it. So this deflection delta is equal to 8W capital D cube into N divided by G into D to the power 4. Now here W is the load that is fixed, N is the number of coils that is also fixed, then capital Z is the modulus of rigidity that is also fixed because it's the same material, and then small d is the diameter of the wire and it is also fixed. So it is, these are all constant. So delta would be directly proportional to capital D cube, that is the mean diameter of the coil. So delta B by delta A is equal to dB cube divided by dA cube. So from here we get delta B is equal to delta A into dB cube by dA cube. Now dB is 2.5 centimeter and dA is 5 centimeter. So our delta B would be equal to 1 by 8 of delta A. So we'll go to next question. The backlash for the spur gear depends upon A, module, B, pitch line velocity, C, tooth profile, or D, both A and B. So the answer is backlash. Okay, what is backlash first? Backlash is defined as the amount by which the width of the tooth space exceeds the thickness of the engaging tooth measured along the pitch circle. So basically, the gap that is there between when two gears meet, so the gap that is there between these two teeth is this backlash. Okay. Now backlash depends on the diametrical pitch or the module and the center distance. The magnitude of backlash is very small for gear trains used in precision equipments and instruments. Okay. Next, backlash per gear also increases with an increase in the pitch line velocity. This is because at greater speeds, the inertia and centrifugal forces cause the teeth to deflect, leading to more clearance between them. So, our option D, that backlash depends on both diametrical pitch and the pitch line velocity, is the correct answer. So, we go to the next question. In cyclic loading, stress concentration is more serious in ductile material, brittle material, both ductile brittle material, or in elastic material. So, the answer is, it is more serious in ductile materials. Basically, if there is static loading, then stress concentration is of no importance in ductile material, but it is of importance in brittle materials. However, when there is a cyclic loading, stress concentration is bad for both ductile and brittle material. However, it is more serious in these ductile materials. Okay. So next question. If the surface tension at the soap air interface is 0.088 Newton per meter, the internal pressure in a soap bubble of 3 centimeter diameter is, the answer is see, internal pressure of a hollow bubble is given by P is equal to 8 sigma by D. Now here sigma we know 0.088, D we know 3 centimeter, that is 3 × 10⁻² meter. So from here we get P is equal to 23.47 Pascal. Now had it been a liquid droplet, the P would have been equal to 4 sigma by D. So next question. If the potential function is expressed as phi is equal to 4 into x square minus y square, the corresponding stream function is, the answer is, see, phi is equal to 4 into x square minus y square. Now u is equal to minus del phi by del x. So u would be equal to minus 8x and v is equal to minus del phi by del y. So it will be equal to 8y. Now stream function del psi by del x is equal to v. So which is already we know as 8y. So from here we know that psi would be equal to 8xy plus a function of y plus c. Similarly, we see that del psi by del y is equal to minus u, which is equal to 8x. Again, psi is equal to 8xy plus some function of fx plus c. Now as we see that psi is equal to 8xy is already a function of both x and y. So what we have is that psi would be equal to 8xy plus c. So option D is the correct answer. So next question. Pelton turbine is used to operate under a net height of 500 meter and at 420 rpm. A single jet with diameter 18 centimeter is used, whose CV is equal to 0.98. Speed ratio is equal to 0.45 and overall efficiency is equal to 85%. The power developed in kilowatt is, so the answer is, it is A. So let us see how we get it. So we know the head, we know the RPM, we know the jet diameter, we know the coefficient of velocity, and we know the speed ratio along with the overall efficiency. Now velocity of the jet V1 is equal to CV into root over 2gh, which we get as 97.064 meter per second. Now area of the jet is how much? It is equal to pi by 4 into d square, which is equal to 0.02545 meter square. Now total discharge would be equal to the number of jets into discharge of one jet. Now total discharge is equal to number of jets. Here as the question mentions that it is a single jet is there. So what we have is a number of jet is 1, and then a velocity into area is gives the discharge of the jet. The velocity we already know 97.064 and discharge we know and area we know as 0.02545. So from here we get the discharge would be equal to 2.4703. So next we see that overall efficiency is equal to shaft power divided by water power. Now shaft power would be equal to the overall efficiency into water power. Now overall efficiency is 0.85 and water power would be how much? Rho gh into q divided by 1000. So it will give in kilowatt. So from here we get shaft power is equal to 10299.298, which is almost equal to 10300 kilowatt. Okay. So go to the next question. If there are no externally induced flow velocities, then the Nusselt number does not depend upon. So the answer is, when there are no externally induced flow velocities, so it is a natural convection, and so the Nusselt number does not depend on the Reynolds number. Okay. So next question. The second law of thermodynamics defines. So it defines entropy. So next question. Which property depends on the surface temperature? So the answer is emissivity depends on the surface temperature of the body and is given by the Stephen-Boltzmann law. Okay. So next question. Piezometer is used to measure. So piezometer is used to measure gauge pressure. Okay. Next question. The friction factor F for a hydrodynamically developed laminar flow inside a circular tube is, so it is equal to 64 by Re, and the coefficient of friction would be 16 by Re. So next question. Which one of the following is an irrotational flow? Okay. So the answer is free vortex is an irrotational flow. Now see, vortex motion can be either rotational or irrotational. In vortex flows, if every fluid element rotates along with the swirling motion of the fluid, then the flow is rotational and cannot be described with a velocity potential. The rotational vortex is commonly called a force vortex. On the other hand, the irrotational vortex is called free vortex. Now, example of free vortex and flow force vortex are like this. Like the swirling motion of a water as it drains from a bathtub is irrotational, so it is a free vortex flow. Okay, and then motion of a liquid in a tank that is rotated about its axis with an angular velocity is an example of force vortex flow. So next question. The range of coefficient of discharge for a venturi meter is, so it is about 0.95 to 0.99. Now what is a venturi meter actually? So a venturi meter is an obstruction type flow meter, and the actual discharge is always less than the ideal discharge, and this ratio of actual discharge to the ideal discharge is called the coefficient of discharge. So next question. The maximum efficiency of transmission through a pipe is, so it is about 66.7%. So next question. The optimum intermediate pressure in case of a two-stage compression is given by, so it is given by P2 is equal to root over P1 into P3. Now this is achieved with perfect intercooling. So what is perfect intercooling? Perfect intercooling means that the temperature of the exiting gas from the intercooler is same as the temperature of the air entering the low pressure cylinder. Otherwise the cooling is called imperfect. So actually why do we need intercooling is that since after the air has passed the low pressure cylinder, it has increased the pressure and the temperature. Now if we can decrease the temperature, what happens is that because the temperature is less, so the intermolecular collisions would be, if the compressor is less, intermolecular collision would be less, and so our work done would be less. So we need to cool it first. Okay, so that is why intercooling is required. So next question. Gas contained in a closed system consisting of piston cylinder arrangement is expanded. Work done by the gas during expansion is 50 kilojoule. Decrease in internal energy during expansion is 30 kilojoule. Heat transfer during the process is equal to, so let us find the heat transfer. So see, from first law of thermodynamics we have Q minus W is equal to delta U. Now W is what? W, it is expanded, so it is positive. So W is positive 50 kilojoule. Now what is del U? Decrease in the internal energy is 30 kilojoule, so del U would be minus 30 kilojoule. Now Q is equal to W plus del U, so it would be 20 kilojoule. Okay. So next question. If the thermal efficiency of a Carnot heat engine is 40%, then the coefficient of performance of a refrigerator working within the same temperature limits would be, so the answer is, see, efficiency of the Carnot heat cycle is 40%, so T1 minus T2 divided by T1 is 0.4. So from here we get T2 by T1 is equal to 3 by 5. Now coefficient of refrigerator would be equal to Q2 by Q1 minus Q2. So from here we get, which is equal to T2 by T1 minus T2, because it is Carnot cycle, so this heat is directly proportional to the temperature. So from here we get, divide both numerator and denominator by T2, we get 1 by T1 by T2 minus 1 is equal to, it is equal to 1 by T1 by T2 minus 1, so it will be equal to 1 by 3 by 5, so it will be 5 by 3, 1 by 5 by 3 minus 1, so it is 3 by 2 or 1.5. Okay. So next question. The absorption refrigerator cycle employs which of the following devices for raising the pressure? So it uses a pump. So next question. A heat pump working on reverse Carnot cycle between the temperature 27 degrees centigrade and minus 13 degrees centigrade. So COP of the heat pump is, so this is the heat pump. So COP is equal to Q1 by Q1 minus Q2, which would be equal to T1 by T1 minus T2. So T1 is 300 and T2 is 260. So our COP would be 7.5. So next question. A room has room sensible heat load of 20 kilowatt and room latent heat of 30 kilowatt. The room sensible heat factor will be, so sensible heat factor is sensible heat divided by total heat. So it would be sensible heat divided by sensible heat plus latent heat. So sensible heat factor is equal to 20 by 20 plus 30, that is 20 by 50 or 0.4. So with this, we have come to an end to the APSC AEGCL 2023 Mechanical Engineering paper for Assistant Engineer Part 4. Hope you like it. See you in the next one. Thank you.